All right, hello everyone and welcome. My name is Jonathan Hill. I am an engineer here at ATA Engineering's Northern Virginia office, and I'm excited to welcome you all today to our webinar, What's New in Simcenter 3D and Simcenter Nastran 2019.2. It's great to have all of you guys on the call so far. Just a quick note that we have muted everyone for now, but we will have a question and answer session at the end. So I invite you to stick around for that, and at that time you'll be able to unmute yourself to ask questions over the phone. And of course, at any time, you can also ask questions through the chat, although I might wait to answer those until the end as well. So let's get started. I have first just a very brief intro to ATA. So ATA is known for our high-value engineering services, where we have expertise in design, analysis, and test. And we're really proud to help our customers overcome their product design challenges across a wide range of industries, some of which are shown here. In addition to that, we're able to leverage our expertise and project experience through our role as a Siemens value-added reseller and partner. So we support a number of product lines, including Simcenter 3D and NX and Simcenter Nastran that we'll be talking about more today, but also FEMAP, StarCCM Plus, and more. We host a technical support hotline that's available all day long, either by phone or through a web interface. We host a variety of training classes and actually develop the official Simcenter Nastran training materials. And so there's a lot that we can help you out with for the software as well. And finally, I'd invite you after today's presentation to check out our software website. We have a lot of really great free resources up there, so white papers and NX Open programs and other on-demand webinars and things like that. And the recording of today's presentation will be posted there probably tomorrow, in addition to being posted on our own YouTube page. So I'd invite you to check those out after today's presentation. So with that, we'll go ahead and just jump right into our main topic, which again is what's new in Simcenter 3D and Simcenter Nastran 2019.2. And again, my name is Jonathan Hill. I'm at ATA Engineering's Northern Virginia office. So just a quick run through of what we'll discuss today. I'll start off by introducing NX Launcher, which is a new tool that comes with this latest release to help us manage having multiple versions installed. So we'll talk about that briefly. Then we'll jump straight into some new features in the software, including selection and graphics updates, meshing, and post-processing. And those three topics will sort of focus on our engineering desktop. So the Simcenter 3D really covers a lot of different disciplines. We're going to focus on engineering desktop, which is central to all of them, and then we'll discuss briefly structures and dynamics a little bit as well. That'll be with the Simcenter Nastran. And then finally, our last point here, additional highlights, we'll just cover some of the other new capabilities that are coming to things like electromagnetics, thermal and flow, acoustics. So there's a lot of great capability, and we'll briefly touch on some of those other topics. So first off, Simcenter 3D and Simcenter Nastran 2019.2 are available to download now. So if you check out these slides after they get posted online, I have a link both to GTAC, where you can download the new version of software, as well as the link to download a new license file. So don't forget to go update your license file at the same time. This release corresponds with the June 2019 release of NX 1872. So you'll hear me use that interchangeably, NX and Simcenter 3D, because we'll recall that Simcenter 3D really is the CAE portion of NX. So I'll be doing some demos today, and I'll actually be demoing from NX itself. But it's the same thing whether you launch NX or Simcenter 3D, you have the same capabilities there. I'll also note that this is the first major enhancement release following the transition to continuous release. So that started in January of this year, January 2019. And that was where we went from NX 11, NX 12 to just plain NX. And then we went from Simcenter 3D 11, Simcenter 3D 12 to Simcenter 3D 2019.1. And now we're here with 2019.2. So just a quick refresher is that what we'll expect now going forward is major enhancement releases every 6 months that will include a schema change. So that means you'll need new license files to run the new versions. If you have a model that is Simcenter 3D 2019.2 or NX 1872, those can't be opened in Simcenter 3D 2019.1 or NX 1847 series of releases. In addition, we'll have monthly maintenance releases. And so if we actually look at where we are right now, we're actually at 1880, so we're 2 monthly maintenance releases into this new version. So I'll actually be showing 1880 today. But within these series, you can go back and forth without license problems or anything. So as promised, I'd like to take a second to introduce the new NX launcher, and this is really geared towards helping us manage multiple installations. And so I guess a little background for this is that in the age of continuous release, each installation is mapped to the same Siemens NX folder of the start menu. So I have a screenshot of my start menu on the top right. Previously, we would have Siemens NX 12 and 11 and 10. Now we just have a Siemens NX folder, and inside that I have an NX shortcut and a Simcenter 3D shortcut. The problem arises that these shortcuts don't tell you what version they're for. And in addition, the shortcut actually points to the most recent continuous release version that you've installed, not necessarily the most recent release of the software. So for instance, in January, I installed NX 1847, so that's what my shortcut pointed to. Then a month or two ago, I installed 1872, and so my link automatically updated to point to 1872. But if I were to uninstall and then reinstall 1847, that's what this link would point back to. So with that challenge and knowing that a lot of users like myself and probably like you guys are interested in maintaining multiple versions on your computer at the same time, whether that is to facilitate working with different projects where you just need different versions of software, there's a new NX launcher program that is available with the 1872 install media. And basically it lets you switch between or choose between launching versions and application and environments. So I have a screenshot over here on the right-hand side. We'll see for environment, I could click here and choose between the different versions that I have installed. And then you can choose your application as well. So in this case, I've set it up so that I can choose between NX, Simcenter 3D, and NX Viewer. But you can specifically choose for your own installation which environments and applications you want to show, as well as you could even launch specific customer defaults and things like that. That's all I'm going to discuss on this for now. I do have a video on our YouTube page that goes a little more in depth in terms of covering how to install it and how to set up the file that controls which environments and applications are available. So I'd invite you to check out our YouTube or click on this link when the slides get posted to learn more about NX Launcher. So stepping into the software itself, we'll start off with some updates to selection and graphics, beginning with some new path selection methods. So there's 4 new methods that are available with Simcenter 2019.2 or the most recent version of NX. Those options are nodes along path, element faces enclosed in path, 2D elements enclosed in path, and nodes enclosed by path. So basically, we have a new option now where we can draw like a box or something on our model, and then we can choose the nodes along the outside or the nodes or elements that are inside that box. So this is a cool new feature that wasn't previously available. There's also some new smart selector options. So if you open that up, you can choose the direction of the loop that you're selecting in. And there are other options here as well, such as if you want to prefer free element edges, what your angle tolerances are, shortest path, things like that. So we'll take a look at this in the demo in just a little bit. In addition to this, we have some new type filter options that allow us to specifically select element edges and element faces. So that's helpful. And then to kind of tie all this together, we now have highlight support for element faces and element edges. Previously, it was sort of hard to select element faces or edges unless you were creating a load for pressure or something like that. So in general, it's just a lot more easy. It's a lot easier to select these entities. And it's great that we have highlight support. So now if we have a group, we can actually check and see what's in that group. Again, we'll look at this during the demo in a minute or two. Continuing on with selection and graphics, there's a new capability that allows users to apply multiple smart selector methods simultaneously. So anytime that you're in a window, for instance, I have a group window here, but anytime you're in a window where you're picking entities, there's going to be this new kind of ... button. And if you click that, it'll open up a Smart Selector Methods box, and this is where you could choose multiple entities or multiple selector methods. And so kind of the example case that I have here, let's say that I wanted to select all of the nodes on all of the edges of my model or on my face or what have you. So I previously could say that I wanted to pick related nodes, and then one at a time, I could go around and start picking all those edges or the faces or whatever I wanted. What I can do now is I can say that I want to pick all of the related edges, say on a body, and I picked all 205 edges at once. And then with just one more click, I could say now I want all the related nodes. So it makes it really easy to combine these different smart selector methods. We'll take a look at this in the demo too, but that's a very interesting new capability. In addition, if we're going to select related element faces, we now have an option if we want to select 2D or 3D element faces. So this would be useful if you had a solid model that had a shell coat or something on it. You could choose if you only wanted to select the 2D or if you only wanted to select the 3D. There's a few updates for points as well. The first being that CAD points now create associative FIM points. So what this means is that if you have a point in the CAD, it'll automatically update the FIM point. And in addition to that, I think this is the really cool feature here is that you can have points automatically become mesh points if they're associated to an edge or to a face. So I think that's a cool new feature. There's also some point display options that are new to us now. So first we can choose whether our point symbol is a plus sign, which is what it's historically been, or if we want to have a circle or a dot. So we'll look at how to change that in the view display settings. In addition, there's a new option to have points displayed through solids. So that's what this picture kind of in the middle is showing, where if maybe we have a large model that we don't want to rotate, or there's a point that we're always referencing, we can have that always displayed through other entities. So again, some useful stuff going on here. We'll also discuss some meshing updates before we go into our first little demo bit. We'll start off by discussing some new techniques that are available for modifying an existing 2D or 3D mesh. So this would be when you have a mesh that's in your model already and you just double click on the mesh to edit it. Maybe you want to change some of the settings or anything. There's expanded techniques that are available for NX to use when it's remeshing that, including the possibility of using the remesh algorithm. You might recall that the remesh algorithm was actually introduced in Simcenter 2019.2, and that's based on some Star CCM Plus capability that is able to mesh, do surface meshes without having to flatten the surface. So it's especially useful if you have bodies that were created from topology optimization or something like that, if they're very highly curved or anything that the traditional mesher might have problems with. The remesh algorithm can handle that, and now that's available with just modifying an existing mesh. So you can see on the right-hand side here, this top mesh would be our traditional mesh, and then the bottom part of this mesh would be where the remesh algorithm has been used. There are new point mesh control options, and that is the spot weld option. So previously, if you did a point mesh control, you were basically just setting the local element size around that point. But now we have a new spot weld option that puts this type of element pattern around your point. And then finally, across the board, there have been some quality and aesthetic improvements for shell meshing. Overall, shell meshing should just be even more robust with this improvement. But to dive a little bit deeper into some of the specific enhancements, there's a new option to minimize triangles, which replaces the previous single triangle option. In addition, there's some improvements to the paver method. The software will try harder to put two elements across the fillet and to have a rib going through the center of that fillet, depending on your element size. Or if you have a smaller element size, it'll fit more elements across the fillet. And there's just in general, more robust meshing. And then finally, this is the final slide for our meshing updates. There's a new method for 1D connection, and specifically it's on the node-to-node connection tab, and it's called Proximity Spider. And this simplifies spider creation, whether that is rigid spiders or if we're doing like stiff beam spider elements or something like that. So there's two options here. The first, you select the core nodes and the leg nodes. So you can create multiple spiders, and there's a tolerance. So basically you pick your center nodes, and you pick your leg nodes, and depending on the distance, any leg node that is within the search distance for center node will be attached. In addition, there's a new select leg only node, and this will create a single spider element connected to all of the leg nodes. And the center node will be the average coordinates of all those leg nodes. So if you have a hole like this, you just select the leg nodes and it'll automatically put a spider centered at the middle. I think these are especially helpful if we have a mesh that isn't necessarily tied to geometry. It makes it really easy just to create all of these even quicker, and especially I think this is probably the easiest way to create beam spider elements. I think that was a little bit of a pain before. And we'll take a look at this in the demo too. I just also want to note while we're on the slide that there are some additional universal connector extensions. So in particular, there is a new ability for bolted joints where the bolt diameter can be automatically detected by the universal connector. There's some solver support options that are new as well, and then finally a new rivet creation method. So with that, let's go ahead and hop over to MX now. And the sample model that I'll be doing today is just this little simple bracket that I put a mesh on. So the first thing I want to show is just some of those new path selection methods. And I'll do that just with groups. You can just right click and create a new group. And my first one, I just want to do the elements. And in this case, I'll do 2D elements enclosed by path. And then remember, we can get to our smart selector options by clicking this button. And this is where I choose my loop direction. And there's other things about, like, if I want to prefer feature element edges and element edge gap tolerance and stuff like that, which method you want to use. I think the most important thing on this tab is to be aware of which loop direction you're specifying. So in this case, I'm picking counterclockwise. The other important thing to note is that for shell elements, the loop direction is assuming that you're looking at the positive side. So you can imagine that it's a different loop direction if I do counterclockwise here, as opposed to counterclockwise on the back face. Luckily, I know that my element normals are all pointing out or down. So I know that I can just come over to this side and now do a counterclockwise loop. And so what I can do is I can just select my element edges, and it'll just let me draw out, it'll just let me draw out this box. And it'll select all of the elements inside there, just like we would expect, so that's great. In addition, we can now select our element faces. Now I can do element faces enclosed by path. And this is going to be something similar. If you don't have paths that line up directly, it'll choose its own path, which also works. We can just do something like that. And we'll select all these element faces. And then finally, I want to select our element edges. In this case, I'm going to use the connected element edges. There we go. And I believe that this feature was available previously. It's just that you didn't have a good way to visualize it after the fact. So I can select all my edges in a row here and say OK. And then if we look at our groups, we have our group of elements, which just like we would expect, highlights, and I can do show only because it has the elements here. It can't show the faces or the edges by themselves. So if I right click, show only is grayed out, and it says there's no displayed entities in the group. But if we highlight it, this is what I was talking about, that it has highlight support now. So this could be really helpful, especially if we're defining like pressure loads or using this for contact or anything like that. I think it's pretty helpful to be able to just select these entity types. Next, I'd like to look at our points a little more. So I have 2 points in this model that are down on the bottom. Maybe this is where this bracket is attached to another part. And I created these as points in the idealized part. And then when I brought it in, it immediately created mesh points. So you can edit if points come in by coming up here and going to edit. And then when we go to geometry options, this is where we can choose whether or not our points from CAD are included in our finite element model. And now we have this new option to automatically create mesh points. So the cool thing here is that if I go back to the idealized part, and I can move these points around, so I can just kind of shift them around wherever I want. And then when I go back to the sim, it'll tell me on this information window that it's gone ahead and created those 2 new mesh points. And we'll see that they're on my model now. So when I update the mesh, it will remesh and then use those points. So I think that's a really great feature that is available now. The other thing we can do is we can choose to control the display for points. If I go to points, again, I can right-click on the points and do Edit Display, or I can come up to View and I can do Edit Object Display up here. So for points, we can now choose to use a circle instead of the plus sign. And in addition, we have this new Show Through command. So I can turn both those on, and then my points will now be transparent, which for a small model like this, maybe doesn't make a huge deal, but if I had a big model that I was always trying to select a reference point or something like that, I could imagine cases where this would be really helpful. You can also change this globally through menu preferences. If you go to the visualization, and now I'm under View Decorations, this is where you can globally toggle on if points are shown through or not. And then I can also control my points if I go to Preferences and then Object. This is where I can control how future points will be created. So again, some new point options that we have. In addition, we can take a look at that new mesh control for points. So previously, we didn't have a spot weld option. You would just select your points and then choose an element size and a radius of influence. So you would get something kind of like that. What we can do now is we can turn on our spot weld, and then we still choose a radius of influence. So this will be the total size of this little pattern that is created. So that's our new mesh control option. I'm just going to undo to go back to our regular model. And then I can showcase some of the remesh capabilities. I guess I'll start off by discussing the new attempt quad only. So I have it off for now. I can't have it on 0 triangles if I want to do the free math or multi-block decomposition, but I can use this new minimum triangles. So we'll see that there's a couple triangles around my model, and if I do this now, it'll just do a good job of reducing most of those. So at least personally, I'm probably going to be using this a lot, just because I think this looks like a cleaner mesh. The other thing that I want to show is there's a new ability down here, CAD curvature abstraction. And if you have sliver faces or anything, it can actually just merge those sliver faces. I'm actually going to start off by just deleting the mesh. I'm going to just recreate this real quick. And then we'll go back to the sim or to the eye part. And I'm just going to put a really weird divide face in here. Again, this isn't something that I would ever do like in a real model. But let's say that we had just a little sliver face down there that, we're going to get small elements, and it's just not what we want. When we come back to the sim, I can do a 2D mesh, and I can check on this CAD curvature abstraction and set a minimum element size. And then what it will do is it will actually just merge these faces together when it creates the mesh. So again, I tend to stay away from the abstraction just because I want to know exactly what's happening with my model all the time. But I do think that this can be a really handy feature, especially if you have some small edges that otherwise would create some kind of nasty mesh underneath them. So finally, we'll look at some of those spider creation methods. So again, those are 1D connection. And then if I go to node, I have a new proximity spider down here. The first option to look at is going to be leg nodes only. So in this case, I can just select all my leg nodes, and it'll create a point right at the center of them. So I didn't have a point or a node or anything in the middle, and it knew to go ahead and create those. So So I'll undo that. I'll create a point at the center now, or a node at the center. And now we can look at that other option, where now I'm going to be choosing my center node on both of those, as well as my leg nodes. And this is the case, it's probably not totally necessary in this case, but it's an easy way to show off our stacked smart selector methods. So I can open this up, and maybe I have a model with more than just 2 holes. Maybe I have a dozen or 20, and I want to do something like this on all of them at once. I can say that I want to select all of the circular edges on my entire part, and I can just select the polygon body in that case. And then when I commit it, now it's selected those 2 edges. And then I can say that I want to select all of the related nodes on those edges. So in like 2 or 3 clicks, now I've selected all 32 of those nodes. Again, not a huge deal on a small model like this, but if you had a bunch of circles spread out across, this is a very convenient way to select all of those nodes. So then when we say OK, and I make sure that my search distance is big enough, then I can go ahead and create those. And just like we'd expect, we get our 2 elements there. You can also use this to create beam spiders, and I think this is one of the areas that this becomes really useful. So if I select these nodes again, maybe I have like stiff beam properties that I want to use, or something. Oops, I selected all those nodes in the wrong place. Here, I'll add those to the target. So we're on our stiff beam now, or on our beam property. And if I change the element, then we have a lot in here, where we would expect to have that stiff beam spider. And that's in comparison to the method that we had available previously, which would just be proximity. And in this case, it's just going to create a single element from each center node, which is probably not what we're looking for. Again, I think these methods are most useful if you have a model without geometry. If I had a model with geometry like this, definitely I think the easiest way is to go point to edge. And then usually I would use point to edges where you actually specify the center and the edge. But what we can do instead is we can actually just do arcs to center. And then at once you can select all the circles on your whole model, and at once it'll just create those spiders. So I think that's probably the easiest way. But again, it's nice to have the variety that they're giving us here. All right, so I'm going to get back to PowerPoint. And we'll continue next with the post-processing improvements that we have. And I'll show most of these back in Next in a minute. So first, we now have the option to control the element display size for springs and lumped masses. So this is available in Post View on the Display tab, and it's only available if you have those mass and spring elements in your model. But you can choose between % of model or a dimension that you can specifically enter in. So again, really great just to keep us from having springs or lumped masses that are way too big or way too small. That's a welcome addition. Then for nodal force reports, which is kind of like a way to do free body reports or free body diagrams. Previously, nodal force reports would only select or would only allow nodes and elements as input. But now you can accept geometry, which I think is really cool. In addition to geometry, you could also do mesh or selection recipes and groups. So we'll take a look at that back on our model as well. The other big thing here is for shell results, we can now project a user-defined coordinate system onto our shell elements and display shell results. So like X or Y direction stresses in a user-defined direction. Previously, that wasn't available. You could do like translations in a user-defined coordinate system, or you could do like the element coordinate system. But it's really great to be able to define your own coordinate system and then project all the shell results in that. And closing out with these last 2 bullets, there's a new way to more efficiently and with the ability to reuse linear combinations of load cases. Now this is limited to linear static loads, and the way that it's set up in an X, you have to have subcases all within a single solution with global constraints. But you end up with the ability to create a table like this, and you can do different scale factors of your different load case subcases. So we'll take a look at that as well. And then finally, for the XY function navigator, editing mode is on by default, which I know I will appreciate. I feel like every time I use XY function navigator, I try to change things, forgetting to turn on editing mode, and then I finally turn on editing mode and make my updates, and then I forget to turn it off, and it doesn't really let you do anything else until it's off. So it's nice that it's just on by default all the time now. Let's take a look at some of these. I'm going to switch to essentially the same model, but now I've created a few different loads. So I have this simple static analysis with 3 subcases. The first are just loads in my global Z direction, so that's just loads straight down. Then I have loads in the Y direction, so that's like horizontal. And then I have loads in the X, but I put them in different directions, so it's going to create like this moment that's sort of twisting the bracket about the constraints, which I've just put some springs and then fixed constraints down here at the bottom. So I can come and look at any of these results. This is from our Z load case, and we'll see that it's just deforming down like we would expect. But I can come up to the display tab, and this is where I can start to change the size of my spring elements. So this will change how big they are. And like I mentioned, you can change between model size, or you can go to, like in this case, I can specify a millimeter size and start to just take better control over what my results look like. In addition to that, maybe I'm looking at a different subcase or the same one, but maybe I'm looking at like element X stresses. There's a new option in the result tab that now will let us choose a new coordinate system. And I don't have a different coordinate system specified in this model, but I could choose a user-defined coordinate system, and then I can check on this box, and that's what will update those shell component results to be in a different direction. So again, really cool capability there. If we go back to look at our nodal force reports, these are actually created after you run the model, and in this case, I ran it with grid point forces on. You just right-click on your solution, and then you say nodal force report, and then you have a lot of options in here. So in this case, I'm going to do a summation of my grid point forces, and I have a few different solutions in there. I'll just use the very first one. So that's my Z loading, so 10 newtons straight down on each side. Next, you choose what elements or nodes you want to include. So I'll just select that face. Again, that's a new capability, being able to select geometry. And then for the nodes, I'll just select this bottom edge. So we'll sum all the loads going from kind of the top part of this bracket down to the bottom. And this is one other new feature that I didn't mention. If we go to our quick pick, which I know at least I use a lot, I imagine you guys are using quick pick a lot too. For a really big model, quick pick ends up having a ton of different entities in here, and it can be hard if you're looking for polygon edge or polygon body or whatever you're looking for. It can just kind of get lost in a sea of other entities that are available in quick pick. There's a new option now. There's just this little filter bar, so I can just start to type in edge, and then it'll only show those results. So this is another, again, I don't have this on the slides, but I think the ability to filter quick pick is something that I'll take advantage of going forward. But anyway, getting back to nodal force report, I can select that edge. I have it checked on to do a force summation, and then I'll just choose a reference point right in the middle of that edge. And then when I say OK, now it's created a new force report down here. See that I already had one in this model. But then from here, I can choose if I want to print that info to the message window. And so here we can see that our force summation is 10 newtons in the Z direction. So that's the load that I applied. That's what I would expect to come out of it. In addition, I could actually plot that summation. And from here, if we come up into our post view, this is where we can start changing the different load cases. You can choose if you're looking at forces or moments, and you can change the units and all that kind of stuff. So again, the new feature here is that we can choose geometry, which is helpful. And then finally, I'll just briefly discuss the new linear combination capabilities. So again, it has to be a linear static solution with global constraints, which is what we have here. So you do this combination by opening results and then right-clicking on structural. I can say combined load cases. And then here I can just start to create in this table. So we'll say like Z plus Y. I can create that. And then now, so these are going to be my subcases down here. And we'll see that the subcases are it's just a title. They're not numbered or anything. But then there's a scale. So I can do just Z plus Y, or I could do like Z plus 2 times moment. I can create that, and then I can add these. The thing that I want to point out is that the columns are not dependent on, like column 2 is not always subcase 2. So it's not just, you just have to pay a little bit closer attention to which subcases you're combining. You can set this up directly in this window, and I could come and start to edit scale factors up here and stuff. There's other options as well. You can export it to a spreadsheet and make your load combinations there. You can also export it and import a CSV file. So this will make it easy to export, modify those combinations, and then import it. Or you can export it and then import it to a different solution or something like that if you want to reuse the same combination profile. But then once you click OK, we come back to our post-processing navigator tab. When I open this up, now we have our new combinations. They're just loaded in here as other subcases. And we'll have all the same results, so I could come and also just start looking through those if I wanted. So that's a quick overview of our post-processing improvements. We'll wrap things up with some Simcenter Nastran enhancements, and we'll start off for solution 401 and 402. So for these two solution types, there's now a new load, which is the ability to simulate pressure load of fluid penetrating between faces in contact. So you can imagine you have something like this picture in the bottom left where we have fluid pressure coming in from the right-hand side, and maybe we have a bolt with bolt preload tightening this down, and then we have contact defined. So the pressure will come in until the faces are in contact. And so for this load type, what you would specify is the potentially wetted surfaces, which in this case would be the top and the bottom, and then you would specify a fluid starting point. And then based on the status of the contact, it would determine whether or not those element faces would have the fluid pressure load applied to them. In addition, also for 401, 402, there is now support for using either engineering or true stress strain data. And then finally, there's just general performance improvements. And these aren't limited to 401, 402. So these are just kind of general improvements. And first, there's just been a huge improvement for MPC equations. So 250-time improvement for MPC equations. So if you have a model with like a lot of rigids or anything like that, I think you'll definitely see some significant improvement. Switching to Simcenter Nastran 2019.2. I know my models seem to be solving a whole lot faster with this new version. And it's probably because of the MPC equation processing. In addition, there's up to 4-time improvement for modal frequency response and direct frequency response solutions, as well as for solution 401 with shell elements. And then finally, this isn't specifically NX Nastran, but if you're using response dynamics or response sim, there's also been a 3-time gain for response sim. So again, just quicker solves, the ability to look at more load cases in less time is always welcome. Now we'll sort of wrap up today's presentation by looking at some of the highlights from other Simcenter 3D disciplines. Again, the cool capability here is that with a single model, we can start to do all of these different physics. We can start to consider them all. So we'll start off just by talking about the brand new electromagnetic capability that has been added for Simcenter 3D 2019.2. And that's both high and low frequency. So for low frequency, we'd be talking about electromechanical and energy conversion devices. So this will be motors and actuators and transformers and things like that. And that's going to be based on the Simcenter magnet solver, which is built on decades of experience, and it comes from Siemens' acquisition of Instalations. The low frequency also includes a 1D circuit tool to help create our current and voltage sources. And it also comes with an extensive electromagnetic material library. In addition to that, there's also high frequency capability, which would be if we were looking at antenna or sensor performance, communications and things like that, plus electromagnetic compatibility and electromagnetic interference, so that would be EMC and EMI, which I think will become increasingly important as devices become smarter and we have more and more forces like this being transmitted between devices and interfering. And for high frequency, there's a suite of solvers that allow us to maximize performance at any scale. Simcenter 3D Flexible Pipe gets an update that allows it to instantly update the pipe configuration after a design change, so you don't have to wait for that solver to like rerun or anything. It should be able to just update on the fly. In addition, there's improvements for Simcenter 3D Flow that include a new immersed boundary method support. So in this case, the only fluid modeling that you would need to do would be a bounding volume with through mesh, and then the solver would resolve solid fluid interfaces automatically. And then finally, for Simcenter 3D correlation, there is an enhanced interface with Simcenter Test Lab. And then finally, to wrap things up, for Simcenter 3D specialist durability, there's now support for parallel computation, so that'll speed up those runs a lot. In addition, we have the ability now to use ANSYS and Abacus results as loading in vibroacoustic or durability simulations in Simcenter 3D. And then there have been some updates to Teamcenter simulation that allow Teamcenter simulation to notify you which solutions or which analyses have been impacted or may be impacted by design changes. So now as the CAD changes, Teamcenter simulation can tell you which analyses you might need to go recheck. So that wraps up my part of the presentation today. I'm going to update the settings so that all of you guys can now unmute yourselves and ask any questions. You can also ask questions through the chat. And so to unmute yourself, whether you're in the web interface or the Zoom application, the unmute button is going to be down in the bottom left-hand corner. If you were in the Zoom application itself, that unmute button is not on the screen share window. It's on kind of a different window that has more controls. So that's where unmute is. And then on the same little menu bar as unmute is where we can get to our chat options. So if anyone has any questions, you're welcome to either type those in or unmute yourself and ask now. Like I mentioned, we were recording today, so we'll have this posted on YouTube as well as our website probably this afternoon or tomorrow. So if you're actually watching on the recording, greetings from the past. I invite you to check out our other resources on our software website though. But at this point, are there any other questions before we wrap things up? Great. So I think we'll go ahead and close the meeting now. But thank you all for joining us today to discuss Simcenter 3D 2019.2. I have some contact info on the board for us, so definitely reach out if there's anything we can do to help out your team. Thanks and have a great afternoon, everyone.